What's going on, guys? Welcome to Regular Expressions Made Easy Part 13, and in this video we'll be discussing a very important topic called word boundaries. This is something I should have gotten to earlier, but I've gotten caught up with groups and some of the other methods. But yeah, this is a very important topic, so I figured I'll use this video to cover it. Okay. So word boundaries are represented by the \w and the \b, and the \b is a meta character. It has a special meaning. So the word boundary allows you to isolate words, and what I mean by isolate words is something I'll show you with some examples later on in the video to get a clearer understanding. But the one thing I want you to understand is that \b, it deals more with location as opposed to consumption. So we have special meta characters that deal with consuming, but \b is more of a location type meta character in that it doesn't consume any characters. It checks your position or your location. So it's very similar to the caret sign and the $sign, which we use to represent the beginning of a string or the end of a string. So let's just get right into some of the examples. So the first thing I should do is I'll make this a little bigger. I guess that's too big. I'll make this a little bigger for those of you who are watching this on their cell phone. All right. So the first thing we're going to do is import regular expressions, and now we have the string. So I want you to pay close attention to the string. Because I've purposely made the string to contain the word cat. So we have cat, Catherine. So the first word cat is an isolated instance of the word cat, and then Catherine has the word cat at the beginning, Catholic, wildcat at the end, copycat at the end, and uncatchable has the word cat inside of the word. So now we're going to compile the string cat. So our regular expression is just going to be this the word cat, or the string cat. So we save that to pattern, and now we're going to use re.findAll to find all instances of cat. Oops, I forgot to run this. So let me just run this, and let's just rerun this. Okay. So as you can see, it actually pulls out all 6 instances. 1, 2, 3, 4, 5, 6 different instances, and that's because with re.findAll, this pattern is doesn't look for the word by itself. It actually just looks for cat, whether it's in a string, whether it has different types of characters to the left of it, right of it. It doesn't care. It will pull out all instances of the word cat to re.findAll. It's not the word cat, it's just cat. So it'll pull out all 3 characters that are together. And this can be problematic when you want to look for certain words by itself. So if you want to pull out the word cat by itself, you're not going to be able to do that with this re.compile cat with this regular expression. So this is where word boundaries comes into play. But before we get to word boundaries, you might think, okay, so what if I put a space? Usually words have a space to the right of them, and in this case, it's at the beginning of the string. So if I have a space to the right of the word cat, then I might be able to pull out the word cat. And that's what I thought. So let's just test that. So using space, same string, and then we have re.compile cat, but what we're going to do is we're going to put a space. So essentially we're looking for a cat and a space to the right of the word cat. So let me just run this, and now we're going to use re.findAll with the pattern string, and as you can see, we pull out 3 different instances of cat. So instead of just getting this first instance, what's happening is we're also pulling out this portion and this portion, because essentially all we're looking for is cat space and cath, but here cat space, and then catch doesn't, this doesn't satisfy, but cat space and cat space and cat space. So we have 3 different instances. So using space still doesn't solve our problem, and even doing this, which is space to the left and right, is actually just going to return an empty string. So pulling out the word cat on its own can be a problem, and that's where we can use boundaries. All right, so let's just get right to it. Same string, and now let's take a look at our pattern, our regular expression pattern. So we have this \b before cat and \b after cat. So essentially we're bounding or creating a boundary around the left of cat and to the right of cat. So essentially we just want to pull out the word cat. And that's what these boundaries are doing. So we run this, and then we run re.find all, and we only get one instance of cat, which is the first instance. So yeah, so that's what our boundaries do. But now I'm going to explain what's happening on a sort of a lower level of what exactly boundaries are doing, because I want you guys to, you guys need to know this to avoid some problems that you might run into. Okay. So here we go. So you have to be careful with periods and non-alphanumeric characters. So non-alphanumeric characters are things like plus, colon, any of these symbols. So alphanumeric characters are any sort of letters and numbers, right? So these are alphanumeric characters, letters, numbers, and also in Python, underscore. So underscore is considered an alphanumeric character, all represented by \W. Non-alphanumeric characters are \big W, and it's everything that's not lowercase w. So it's all these letters, it's spaces, all these sort of special characters are usually represented by non-alphanumeric characters, \uppercase W. Now, I'm going to show you what the problem is. So we want to pull out the word cat on its own, but in this instance, we actually put a period, a non-alphanumeric character to the left of cat. Since this is not actually what we want to pull out, remember we just wanted to pull out instances of cat, so we put the boundary, and we think, okay, so this should have no problem. And we run it, and it actually pulls out the cat. It pulls out this portion of the cat without this period. And this is not something we want. We only wanted to pull out instances of cat that are sort of isolated. But here, there's a period to the left of cat, and we're pulling it out. And this is what I want you guys to be careful of with word boundaries. So essentially what word boundaries does is, remember, word boundaries don't consume anything, it's just sort of holds the location. So in this case, since we're putting a word boundary to the left of C, what it does is the cursor is here, to the left of C and to the right of this period. So what a word boundary does is it checks, it makes sure that to the right there's a character, and then to the left there's a non-alphanumeric character. That's how it actually pulls out isolated words. So it'll check and make sure at least one side has a character and the other side has a non-alphanumeric character. So if we check to the right, we have a character, and to the left, we have a non-alphanumeric character. Now, a space is considered a non-alphanumeric character. So what the boundary does is it checks to the right as an alphanumeric character, and then it checks to the left, and it makes sure there's one non-alphanumeric character. Or it makes sure that there's at least one non-alphanumeric character. So let me just explain that again, just in case it was confusing. What the boundary does is it looks at both sides and makes sure at least one side has a numeric character, alphanumeric character, and the other side does not have an alphanumeric character. So with something like Catherine, since we have a boundary at the beginning and at the end, what happens is there's a boundary here. It checks to the left. Okay, there's a alphanumeric character. That's okay. But to the right, there's also another alphanumeric character, so this doesn't satisfy. Same thing with here. It checks to the left, it checks to the right. Here, checks to the left, checks to the right. This is good, but remember, we have two boundary characters, so it's going to check at the beginning of C as well. Checks to the left, checks to the right, two characters. So that's a problem. A space is considered a non-alphanumeric character. So here, if we check to the left, it's actually an empty string. Yeah, I guess it's not really a space, it's an empty string, and that's considered a non-alphanumeric character. So here, to the left is nothing, to the right is C. This satisfies the condition, and then, so there's a boundary after T as well, so it checks to the right, and then it checks to the left. Checks to the right, there's non-alphanumeric character, checks to the left, alphanumeric character, so this string satisfies this regular expression. Now, just by putting a dot here, this dot actually represents a non-alphanumeric character. So this dot is essentially the same thing as an empty string. And that's why we run into this problem that we pull out the cat despite it actually not being isolated. So that's one thing you have to be careful of with boundaries. So if I run this, as you can see, it pulls out the cat. Yeah, so now I'm going to just show you another example of a non-alphanumeric character, and that is an at. So if you're trying to pull out the word cat on its own, this is going to get pulled out as well because at sign is also a non-alphanumeric character. So in this case, invalid syntax. Okay, run this. Okay, run the string. Okay, so we pull out two instances of cat, and that's because we have an at cat and cat. So here's another case of at non-alphanumeric character. All right, so now that we have an idea of how boundaries work, now I'm going to just go into an example of how we can use it. All right, so this is another contrived example. It's going to use Twitter handles. So we have 4 different strings, 1, 2, 3, 4, and at Mundra and at Mundra _ Python. So these are valid Twitter user handles, usernames. Python at Mundra is more like an email address, so this is actually not a valid Twitter username or Twitter handle, and I'm pretty sure you can't use periods, so .org, so this first string as well is not a valid Twitter handle. So what we want to do is we want to use what we came up with, these boundaries, to actually pull out the two valid Twitter handles. So at Mundra is valid, and at Mundra _ Python is valid as well. Okay, so how would we do that? Okay, so the first thing I thought, okay, maybe we'll put word boundaries. We'll use word boundaries around here and here. So putting, having word boundaries here and here excludes this, right? So at the very least, it'll exclude this. So we have pattern re.compile. We have a word boundary with at, and we're going to use a custom character set that's going to include \w. So now, one thing you guys be aware of, remember, \w contains all letters, all numbers, as well as underscore. So this also fits into this criteria. So we have an at, and then we have a bunch of letters. So this should work, and I'm assuming this should work as well. This is probably going to be a problem. So let's just run this and see what happens. All right, so I run this, and of course I need to run the string first, and I run this, and it pulls out nothing. So why is it pulling out nothing? And the problem is this special character. So this is actually a non-alphanumeric character. Remember, a word boundary wants one side to be a non-alphanumeric character and the other side to be an alphanumeric character. But here, if we put a word boundary, we're going to have a non-alphanumeric character, and to the left of it, we're going to have another non-alphanumeric character. So as you can see, that's a problem. So we're not going to be able to pull out string number 4. So let's look at string number 3. If we look at string number 3, there's an alphanumeric character, and then there's a non-alphanumeric character. So this should work with string number 3. So let's run string number 3, and as expected, we get a match. We're able to pull out at Mundra because there's an alphanumeric character and there's a non-alphanumeric character. Okay, so let's look at the other ones. String 2, nothing as expected, and string 1, nothing as expected. Alright, so this, unfortunately, this solution is not going to work. So let's take a look at a solution that may work. Let me get rid of this. Okay, so let me just and bring it here so you guys can still take a look at the string. Okay, this is actually an interesting solution because we're using the opposite of \b. So \b is a word boundary looking for either one side with alphanumeric and the other side with non-alphanumeric. Now \B is actually the opposite. So it's looking for either both sides with alphanumeric or both sides with a non-alphanumeric. So it's the opposite of \b. \b, what it does is looks for one side with alphanumeric, one side with non-alphanumeric. So \b is going to look for both sides with alphanumeric or both sides with non-alphanumeric. So let's take a look at this. Okay, \b. So we should have this, right? These at signs should be no problem because the both sides are going to include non-alphanumeric characters. So the right side is this and the left side is an empty string. So this should be no problem. So let's run string number 4. So string number 4 at Mundra Python. Okay, that looks good. Now string number 3. We shouldn't pull this out, and we don't want this because it's going to have one side with alphanumeric and one side with non-alphanumeric. So let's run this. Okay, so it doesn't pull it out. So that's good. Okay, so let's say if we run 2. Okay, so string 2 is something we want to pull out. So let's just run this and see what happens. Okay, so it pulls out string 2 as well. Now string 1 is something we don't want to pull out, and we'll run this and see what happens. And it pulls out string 1 as well. So at Mundra 2017, and it forgets this .org. So this is not something we want to pull out because it has the .org. So this could be some sort of email address that we're pulling out. So why is it pulling out this .org? Because this is once again considered a non-alphanumeric character. This boundary here, what it does is it looks for an alphanumeric character on one side and a non-alphanumeric character. So this is an alphanumeric and this is a non-alphanumeric. So this boundary is pulling that out. And that's not something we want. So what can we do to avoid this problem? So in this case, see, our strings are pretty simple. So yeah. So one of the things we can do in this case is just put a $sign. So remember, the $sign represents the end of the string. So in this case, let's see. Let me just copy this. Okay, so we'll put it here. Okay. So we have these 4 strings. Now if we put a $sign, remember the $sign means this is the end of the string. So in this contrived example, this is going to work, it seems, because we want alphanumeric characters, as many of them, and then it ends. That's the end of the string. So in this case, it's not the end of the string because it still has this .org. So this is not going to be satisfied. This will be satisfied. This is not going to be satisfied, and this will be satisfied. So in this case, this works. So if I run this with string, it's not going to pull out string. We're not going to get any results from string. But if I run string number 2, so string number 2, string number 3, and string number 4, we want string 2 and 4 only. So if I run this, string 2 we get at Mundra, string 3 we get nothing, and at string 4 we get at Mundra Python. So in this case it works because this is technically the end of the string, at Mundra Python, and then end of the string. But if it was something like, say we had a list of Twitter handles, at Mundra, something like this wouldn't work. In this case, we want to pull out all 3. So let's see what happens in this case. So if we, let's see how many we pull out. So we only pull out 1 because we're using this $sign. So we're only looking for Twitter handles that end with some sort of alphanumeric character. So in this case, we're only pulling out, actually, I'm using re.search. Let's see, re.findAll. Let's see what we can pull out with re.findAll. So here we go, re.findAll, we only pull out this, 1 instance of the Mundra instead of all 3. So if you had a list of Twitter handles, this wouldn't work, and this is easily breakable. But for this contrived example, this works pretty well. There is actually a way around this. It's something utilizing something we haven't done yet. It's called turnaround. It's something I've been meaning to get to, but it's a little complicated. But let's see, re.compile, and in this case, we'll just copy this. So I'll show you that there is actually a way. It's sort of complicated, but let me see. Okay, so we have this. What we want to do is we're going to put a boundary here first. So let's see what this boundary does. Okay, so string, we have the string pattern equals this, re.findAll, pattern, and string. Okay, so we're going to start off with string 1. If I run this, unfortunately we get 1, but let's just make sure we get string number 2. If I run string number 2, okay, so I only get 1 instance of string number 2. I have to actually run string. Okay. Okay, so we get all 3 instances of string 2, which is what we want, and string 3, we get nothing, which is good, and string 4, we get what we want. So string 2 and 4 are what we want, and they work, and string 1 is something we don't want. So the problem here is that we don't want this period. And to do that, we could actually use something called a negative lookaround. And this is something I haven't taught you guys, and I plan to teach you guys. So this is a negative look ahead. So it just looks ahead and says, okay, we don't want a period. but it doesn't consume anything. So we're going to use a period, and we're going to use a backslash before the period to negate the period. So essentially we're saying we don't want a period. We want this word, but then we don't want a period afterwards. So this will negate this entire string or any email addresses that look like a Twitter handle. Let's just run this. So string 4 works. Let's see, string 3 doesn't work, which is what we want. Now string 2 is a tricky one. Let's see if we pulls out everything. Okay, Mundra pulls out all 3. Now let's just hope that string 1 doesn't work with this negative look ahead. And string 1 doesn't work. Okay, so this is how you solve the problem using negative look aheads. Okay, so I think that's it with word boundaries. So remember, it's used to isolate words. So it's very useful to isolate words. So we want to capture words that are not part of other words. And the only thing you have to be careful of is if there is non-alphanumeric characters such as period or these weird symbols that are prefacing the words. Okay, so yeah, and then we went over an example with the Twitter handles, and the Twitter handles was actually meant to show you the usage of backslash capital case B. So in this example we used capital case B as well as lowercase b. Hopefully this give you an idea of backslash uppercase b and backslash lowercase b. Okay, so yeah, so that's it for this video. I will see you guys next time.